Sinusoidal functions. We have several learning goals in this unit. The one we're going to focus on today will be understanding the effect of applying transformations to sin x and to cos x. Back at the beginning of the semester, we talked about this general equation. This equation is some general function f that we're applying transformations to. So we have the transformation a, k, d, and c. Do you recall what these do? When we studied this function in February, we talked about a being the vertical stretch or compression, but also whether it reflects the x-axis if it's negative. We said that c was moving the entire function up or down. K works on the x, and then it determines the horizontal stretch or compression. And if it's negative, it reflects in the y-axis. And then finally, d is moving our function left or right. So these are the same as what we studied back in February. When we work with sinusoidal functions, we can use exactly the same transformations. So a will be our vertical stretch and compression, k our horizontal stretch and compression, d our horizontal translation, left and right, and c our vertical translation up and down. This slide reveals what a, k, c, and d do for all functions, not just the sine function. This slide extends our learning about transformations and applies it specifically to sinusoidal functions. So when we talk about vertical stretch or compression, that's actually going to be the amplitude of the sine curve. When we talk about horizontal stretch or compression, that number, k, will help us determine the period. So our period will be equal to 360, which is the usual period for a parent, divided by the k value. Horizontal translation is known as phase shift in sinusoidal functions. And the vertical translation up and down, that will be the equation of the axis. So that will be the line that the wave is the equivalent distance from, max and min. Given the parent in this picture, sine x, what would happen if we now have 5 sine x? Or if we have sine 5x? Now consider the previous screens where we talked about which transformation is happening in front of the function and which transformation is happening in front of the x. Similarly, given the parent y equals sine x, right here, what would happen if I have a new function, sine x plus 5? What about a new function, 3 sine x minus 2? We'll continue with our predictions. Again, we start with the sine x. We could start with cos x, but I happen to choose sine x. Predict what will happen if I have sine 20x. Is this a, k, c, or d? And what effect will it have on this curve? What about sine 1/5 x? Thank you, and I hope you did well with your predictions.